Question number 9. A ball is dropped from a height of 19.6 meters above the ground. It rebounds from the ground and rises itself up to the same height. Take the starting point as the origin and vertically downward as the positive x-axis. Draw approximate plots of x versus t, v versus t, and a versus t. Neglect the small interval during which the ball was in contact with the ground. So here we write the equation of motion x equal to ut plus half gt square. Here g is 9.8 meter per second square. So here u is 0. So x equal to half gt square. Now we write the value of t and the corresponding value of x. When t equal to 0, x will be 0. When t equal to 1, x will be from here 1 by 2. This is 9.8 times t square. So 4.9 meter. Then at t equal to 2 seconds, this will become 1 by 2 into 9.8 into 2 square. So it will become 19.6 meters. It means ball has reached the ground. So the situation is shown here for 1 second, for 2 seconds, it is here. This is 20 meters, so it is at 19.6 meters. Now, suddenly, it rebounds. So when x equal to 3 seconds, then the process will be repeated. So again, we will start from here. So this will be 4.9 meter. Here, 3 seconds means when ball rebounds starting from 0. So this is 1 second. Then again, for 4 seconds means 2 seconds from the point it rebounds. So this will become 19.6 meters. So situation is shown. So ball will cover 19.6 meters. It means the point from where it was dropped, it reaches again at the same point. So that is equivalent to 0. So this is starting point. Now after rebounding, it reaches to the same point. So graph is like this. Now, second point, we have to plot the graph v versus t. So velocity vt graph. Vt graph will be v equal to u plus gt, and this is the situation when ball is coming downwards. It starts from west. So at t equal to 1 second, velocity will be 9.8. So here t, and this is velocity. When this is 0, so this is 0. When t equal to 1 second, velocity will be 9.8 meter per second. And at 2 seconds, velocity will become 19.6 meters per second. So this is corresponding value for 1 second. Velocity is almost here, just below 10 meters per second. So at this point, and at t equal to 2 seconds, velocity attains 19.6 meters per second. Now, suddenly it rebounds. So this is position change. Now it starts moving up. So initial velocity will be same 19.6 meters per second, but it will decrease. So at third second means 1 second from the point of rebounding, its velocity will decrease. So that is 19.6 minus 9.8 into 1. So it will become 9.8. Okay, we will take this time velocity, this negative, this positive. So this will correspond to this point minus 9.8 meter per second. Then When time becomes 2 seconds, so this velocity will become 0. So this corresponds to that point. So this is VT graph. For first 2 seconds, it will be like this. Then for next 2 seconds, it will be like this. As far as acceleration time graph is concerned, acceleration remains constant, except at the point when ball rebounds. It changes its direction. So we have to ignore that point. And after that, again, acceleration will remain same as 10 meter per second squared. Now, question number 10. A stone is dropped from a balloon going up with a uniform velocity of 5 meters per second. U equal to 5 meters per second. So use like this, so we can write it negative. Acceleration due to gravity will be like this, downward. We can write it as 10 so meter per second square. And the height from where it was dropped, h, is 50 meters. We have to find out the time when the stone touches the ground. So for that purpose, we write S equal to ut plus half at square. Here S is 50, u is negative 5, t plus 1 by 2 into 10 into t square. So this becomes a quadratic equation, 5t square minus 5t minus 50 equals 0. We can divide each term by 5 to get t square minus t minus 10 equal to 0. Now we can get the value of t. So t will be equal to plus 1 plus minus root of minus 1 square, that's 1 minus 4ac, 4 into 1 into minus 10. So this will become plus 10 divided by 2 into 1. So this becomes t equals 1 plus minus root 41 divided by 2. We take positive value of t. So t will be equal to 1 plus root 41 divided by 2. If we evaluate it, it will become 3.7 seconds. Now, in 3.7 seconds, initially, the balloon was here. Now, balloon will reach to certain height. Suppose this is, say, we write it as h1, and already this height was 50 meters. So we have to find out the height of the balloon from ground now. So height of the balloon from ground equal to 50 plus speed of balloon. It is 5 meters per second into time 3.7 seconds. So this will be equal to 50 plus 18.5. That becomes 68.5 meters. And that is our answer. Thank you for watching.